In this video, we're going to continue looking at different methods for counting the number of possible outcomes. And so here we're going to look at something called the fundamental counting principle. If we want to perform a series of tasks, and the first task can be done in A ways, the second task can be done in B ways, the third can be done in C ways, and so on, then all the tasks can be done in A times B times C and so on ways. So this is the fundamental counting principle. Basically, this is a multiplication rule that allows us to multiply. So in example 1, we're going to begin by revisiting a couple of examples that we've seen previously. Example 1. If a coin is flipped twice, how many different outcomes are possible? Well, this time, instead of doing a systematic list like we did in previous videos, I want to use the fundamental counting principle. So in this particular case, we're going to flip a coin twice. We want to know how many different outcomes are possible. Well, we can use the fundamental counting principle as follows. Think about the first flip. So if you think about the first flip, there are two possible outcomes. It could land on heads or it could land on tails. And if you think about the second flip, there are two possible outcomes. Again, it could land on heads or it could land on tails. So if I'm flipping the coin twice based on this fundamental counting principle, there will be 2 times 2, which equals 4 different ways that the results can occur. So in other words, there's 4 different outcomes that are possible. And again, we listed those previously. In a previous video, we actually listed those as heads, 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 tails, tails, heads, or tails, tails. So we listed those outcomes previously. Here we didn't really want to list them necessarily. We just wanted to determine how many different outcomes are possible. Similarly, if we look at part B, if a coin is flipped 3 times, how many different outcomes are possible? Well, again, we can think about the first flip, we can think about the second flip, and we can think about the third flip. So the first flip, there's 2 outcomes. The second flip, there's 2 outcomes. The third flip, there are 2 outcomes. So altogether, there's going to be 2 times 2 times 2 outcomes. And 2 times 2 times 2 equals 8. So there's 8 different outcomes. There's 8 ways that the result could occur. And again, previously in a video, we actually listed those 8 outcomes. So they were heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. We literally listed those in a previous video. Here we didn't actually have to list them. We just needed to determine how many outcomes are possible. And we've determined by the fundamental counting principle that there's 8 different outcomes possible. So now what if we generalize? If a coin's flipped 4 times, how many different outcomes are possible? Well, think about the first flip, the second flip, the third flip, and the fourth flip. So there's 2 outcomes on the first flip, there's 2 outcomes on the second flip, there's 2 outcomes on the third flip, there's 2 outcomes on the fourth flip. So there's 2 times 2 times 2 times 2. Notice, by the way, that's 2 to the 4th. And if we multiply 2 times 2 times 2 times 2, that is 16 different outcomes. There's 16 different ways that these results could occur. Now we could list those as well. We're not really asked to list those, so I'm not going to, but we could. D. If a coin is flipped 10 times, how many different outcomes are possible? Well, do you see the pattern that's happening here? So I would have 2 outcomes for the first, 2 outcomes for the second, 2 outcomes for the third, and the fourth, and the fifth, and the sixth, and the seventh, and the 8th, and the 9th, and the 10th. So there would be 2 to the 10th power different ways that this could occur. So if I pull in my calculator, 2 raised to the 10th power is 1024. there would be 1,024 different outcomes that are possible. There's 1,024 different ways that we could get heads and tails results. Look at example 2. If two 6-sided dice are rolled, how many ways can the dice land? Well, we've actually looked at this previously as well. In a previous video, we looked at the different possible outcomes. And so we determined before that there's 36 different ways the dice could land. So we know the answer. What's that have to do with the fundamental counting principle? Well, if we think about the first die and we think about the second die, how many different ways can the first die land? It could land 6 different ways. How many ways can the second die land? It can land 6 different ways. And so if we multiply 6 times 6, that's 36 different ways that the dice could land. And so again, we literally have those different ways shown right here in this figure. So 36 different ways. So could we generalize that? In the game of Yahtzee, 5 6-sided dice are rolled. How many different ways can 5 dice land on a single roll? Well, we have the first die, we have the second die, we have the third, we have the fourth, and we have the fifth. So we have 5 different dice. So 6 ways for the first die, 6 ways for the second die, 6 for the third, 6 for the fourth, 6 for the fifth. So altogether, the dice could land in 6 to the 5th power different ways. So if I pull my calculator in, 6 raised to the 5th power, that is 7,776. So there's 7,776 different ways that the dice could land when we roll 5 dice one time. There's 7,776 different outcomes. Example 3. We've seen this one before as well, but now we're talking about the fundamental counting principle. The fixed price dinner at Mel's restaurant has the choices below. How many different meals can be ordered? Well, for appetizer, we have potato soup or garden salad. For entree, we have baked chicken, sirloin steak, roast beef, or meatloaf. And for dessert, we have vanilla ice cream or cheesecake. And again, our question isn't what the different choices are, just how many are there. So if we think about our appetizer, for appetizer, we have 2 choices. For entree, we have 4 choices. And for dessert, we have 2 choices. So altogether, there's going to be 2 times 4 times 2 different meals possible. Well, 2 times 4 is 8, and 8 times 2 is 16. So there's 16 different meals that are possible. And again, in the previous video, we actually listed what those meals were using a tree diagram. So here we don't really need to list them all. We're just asked how many could be ordered. There's 16 different meals that could be ordered. So let's finish this video out with a few more examples. Example 4. A man has 3 pairs of shoes, 5 pairs of pants, 6 shirts, 4 ties that all match. How many different outfits can the man wear? So if he mixes up the shoes and the pants and the shirts and the ties, assuming they all match, how many different outfits could he possibly have? So if we mix and match the shoes, the pants, the shirts, and the ties, how many choices does the man have for shoes? Well, he has 3 pairs of shoes, so 3. How many choices for pants? He has 5 choices for pants. Shirts, he has 6 choices for shirts. And ties, he has 4 ties. So he would have 3 times 5 times 6 times 4 different outfits that are possible. So if I pull in my calculator, 3 times 5 times 6 times 4, that is 360. So he has 360 different outfits that he could wear by mixing and matching his 3 pairs of shoes, 5 pairs of pants, 6 shirts, and 4 ties. Example 5. Jill has 12 songs saved on her smartphone. Jill sets the player to randomly play songs without repetition until all 12 songs have played. In how many different ways can the songs be played? So again, this is a random playlist that's occurring, and no song can repeat until all 12 have been played. So the question is, how many different ways can the 12 songs be played? Well, so if we think about what's going to be the first song, the second song, the third song, the fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, and 12th songs. So again, when we first start this random playlist, for the first song choice, there's 12 different songs that are possible. But now, whatever that first song is, it can't play again until the others have played. So for the second song, there's only going to be 11 choices left. For the third song, there's only going to be 10 choices left. And for the fourth song, there's only going to be 9 left, and 8 left, and 7, and 6, and 5, and 4, and 3, and 2. And for that 12th song, there's only going to be 1 choice left. So it would be whatever 12 times 11 times 10 and so on is. So let's do that. 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that is a bunch. So if we take a look at that, that is 479,001,600. So that is 479, 001, 600. So that's a lot. Believe it or not, 12 songs, those could occur in 479,001,600 different ways. Now I do want to point this out quickly here for you. We'll see this notation in the next section, but when we have a number like 12 times 11 times 10 all the way down to 1, we have a notation that we use for that. We put 12 with this symbol behind it that looks like an exclamation point. Well, in math, that's not an exclamation point. That symbol is called factorial. So this is 12 factorial. So 12 factorial means 12 times 11 times 10, 9, 8, all the way down to 1. We'll see that more in the next section. Take a look at example 6. Companies whose stocks are listed on the New York Stock Exchange have their company name represented by either 1, 2, or 3 letters, and repetition of letters is allowed. What is the maximum number of companies that can be listed on the New York Stock Exchange? Now this problem is a little more complicated because we have 3 different scenarios that are possible. A company listed on the New York Stock Exchange can either be listed by 1 letter, by 2 letters, or by 3 letters. And just to give you an example of that, I believe F is Ford on the New York Stock Exchange, so they use the symbol F for Ford. So that's a 1-letter symbol used to represent Ford. Now, a 2-letter example, MA, is MasterCard. So MasterCard is represented by 2 letters. A 3-letter symbol, WMT, is Walmart. So again, that would be a 3-letter symbol. So again, a company could either be represented by 1 letter, by 2 letters, or by 3 letters if it's represented on the New York Stock Exchange. So for this problem, what we have to figure out is how many 1-letter symbols are possible, how many 2-letter symbols are possible, and how many 3-letter symbols are possible. And then if we add those up, that'll give us the total number of companies that can be listed on the New York Stock Exchange. So if we have 1 letter, well, there would only be 26 different companies that could be represented by 1 letter. So that would be A through Z. But if we have 2 letters, well, that could be AA, AB, AC, AD, and so on through ZZ. So for 2 letters, well, there could be 26 different possibilities for the first letter, and there could be 26 different possibilities for the second letter. So if I take 26 times 26, that is 676. So there are 676 different 2-letter companies that could be represented on the New York Stock Exchange. Well, what about 3 letters? Well, there could be 26 choices for the first letter, 26 choices for the second letter, and 26 choices for the third letter. So again, that would be like AAA, AAB, AAC, AAD, and so on through ZZZ. So if I take 26 times 26 times 26, that is 17,576 different companies that could be represented with 3 letters. So there's 26 companies that could be represented by 1 letter. There's 676 possible companies that could be represented by 2 letters. And there's 17,576 different companies that could be represented by 3 letters. So altogether, if we add that up, the 1-letter companies plus the 2-letter companies plus the 3-letter companies. So if I add that up, 26 plus 676 plus 17,576, that is 18,278. So there are 18,278 possible companies that could be listed on the New York Stock Exchange. Last but not least, example 7. In Ohio, a license plate consists of 3 letters, A through Z, followed by 4 digits, 0 through 9. Assume that all letters and digits may be used, except that the third letter cannot be 0, I, or Z. If repetitions are allowed, how many different license plates are possible? So in Ohio, we have license plate numbers, so to speak. So it again consists of 3 letters followed by 4 digits. So we have 3 letters and then 4 digits. So here's letters and here's digits. Digits meaning numbers. So again, repetitions allowed. All letters and digits may be used except the third letter cannot be O, I, or Z. I suppose O could be confused with 0, I could be confused with 1, Z could be confused with 2. So those aren't allowed apparently as the third letter. So for the first letter, O, I, and Z are allowed apparently. So for the first letter, there's 26 different possibilities that could be that first letter, A through Z. And then for the second letter, again, O, I, and Z seems to be allowed for that. So there's 26 different letter choices for the second letter. But then the third letter can't be O, I, or Z, so there would only be 23 choices for that third letter. So the letters could occur in 26 times 26 times 23 different ways. Now again, it says that all digits can be used. So for the digits, that could be anything from 0 through 9. So that is 10 choices, and 10 choices, and 10 choices, and 10 choices. So there would be 10 times 10 times 10 times 10 different choices for the 4 digits. So there would be 26 times 26 times 23 times 10 times 10 times 10 times 10 different license plates possible. So if we do that, 26 times 26 times 23 times 10 times 10 times 10 times 10, that is 155,480,000. So 155,480,000 different license plates would be possible in the state of Ohio under this scheme for assigning license plate numbers. This concludes this video for Section 12.2. You should now be able to handle the Section 12.2 homework assignment.